These difficult Module 2 questions showed up for the first time on the May SAT, and most people were absolutely cooked. In this video, we're going to be going through these questions with in-depth solutions from a perfect scorer on the SAT. The whole video has timestamps, so if you just want to solve them on your own and check your answers with mine, you can skip ahead to the end of every question. Alright, so let's start off with our first question for the video. And so this is actually a kind of new question on the SAT. It's pretty common for the SAT, especially in Module 2 on those harder questions, to ask you constant questions, but this is a little kind of a different way of them asking it. So let's get right into it, right? The function h is defined by this equation where b and c are constants. And in the xy plane, this graph of this equation contains these 2 points. If h of m equals 0, what is the greatest possible value of m? Right? So when you see questions like this, the first thing you want to know is how can I find those constants? How can I find the value of b and how can I find the value of c? And they're giving you these points, so it's pretty clear that they want you to plug them in, right? And as you do more problems, you'll understand that you need to plug those in. So right here we can see we have this point 2 comma 0, so let's plug that straight into the equation, right? So h of 2, right, so x is equal to 2, is equal to 0. But it's also equal to, if we just plug it directly into the actual equation, negative times the square root of x squared, right? But here we have 2, right? X is equal to 2, so 2 squared plus b of x, so b of 2 plus c, right? So really, what is 0 equal to? Well, it's equal to negative times 2 squared, which is 4, plus 2 times b plus c. And this is all equal to 0, right? So if this is all equal to 0, right, then what can we do to actually find b and c? Well, we can first multiply both sides by negative. So we'll get square root of 4 plus 2b plus c equals, well, negative 0. Well, that's still 0. Right now we can square both sides. The left side will still stay 0 because 0 squared is 0. And then this side, this left side, will be 4 plus 2b plus c, right? But we still have two variables we need to solve for. We can't do that with just one equation. So now let's plug in the other point we were given, 0 comma negative square root of 266. So let's plug that into the equation, right? So in this, we know that it's equal to negative square root of 266, but we also know it's equal to kind of the same thing that we did here, plug in the x value that they gave you. So they gave us the x value of 0, so let's plug that in, right? So the equation is x squared, or sorry, negative times the square root of x squared, so that's just 0 squared, so that's just 0, right? 0 squared, right? And then we have plus b of x, well, 0 times b is just 0, and then plus c. So it's pretty clear that here, now on the left side, we have square root of negative 266 equals negative square root of 0 plus 0 plus c, right? So 0 plus 0 is just 0. 0 plus c is c. So now you can see that we've basically found the value of c. Just cross out the negatives on both sides, square both sides, and we'll get 266 equals c. Now coming back to this equation on the right, what were we missing? Well, we wanted to fill in one more variable. We can do that. 4 plus 2b plus c. But what is c? Well, we have it. 266 equals 0. So if we combine 4 and 266, we get 270 plus 2b equals 0. So we can go ahead and move the 270 to the other side, so subtract it from both sides. You get 2b equals negative 270. Now all we need to do, divide by 2 on both sides. We get b equals negative 135. And now we know what b is, which is negative 135. And we know what c is, which is positive 266. So now we can move on to the next part of the question. So let's just go ahead, kind of erase all this previous work, and really move on to now kind of the easier part of the question, right? Which is what they were actually asking us for, right? So what they were asking us for is if this equation is equal to 0. So let's write out the equation. Now we have it, negative times the square root of x squared plus b of x. Well, we already solved the value of b. It's negative 135. So minus 135 of x, and then plus c. Well, we just solved for c, and it's 266. So now all of this is equal to 0. What value of x makes it equal to 0? Well, let's multiply both sides by negative, and let's square both sides. We're going to get x squared minus 135x, or minus 135x plus 266 is equal to 0. It's pretty obvious now that we need to factor and solve for the values of x. So let's use Desmos to do this because it's way easier to use Desmos, right, than deal with these big numbers. So looking at Desmos, I already have it put in, but I'll just show you. X squared minus 135x plus 266 is equal to 0. And we want to find the greatest possible value of m. So really, which is the greatest possible value of x, right? So x could be 2. So if we plug in 2 into this equation, it'll equal 0. But also, if we plug in 133 into this equation, it'll equal 0. So the greater between those two is 133. And boom, that's actually our answer. Our answer is 133 because that is the greatest possible value of m, where h of m equals 0. So boom, that question is done. This is just a geometry question, which the SAT loves, but it's slightly different than some of the past ones, so let's just go straight into it. And again, this is from another past SAT. So a right rectangular prism has a base area of 32 square centimeters. The length of the base is 8/3 of this rectangular prism, and the height of the rectangular prism is 3. Which expression represents the surface area of this right rectangular prism? Well, the first thing that I notice here is that, we have this constant here, t, but our answer choices also have t, so we don't have to solve for t. Another thing, with any geometry question in the SAT, you need to be drawing a diagram, so that's what I've done here. Always draw yourself a visual. All I did to draw this, I just drew a rectangle like this, another rectangle that matches up, and then you just connect these lines, and it looks like a rectangular prism, right? Now, I also labeled it, so we have our height of 3, and then this is our base of 32 that you can see here, and it has a length here, 8/3, and it has a width here, which we don't actually have. We're not given. And then the height of the entire rectangular prism is 3. Now we're given which expression represents the surface area. There is a way that you can kind of visually answer this question, or just looking at the visuals, but I think it's actually safer to just stick with the formula. So there is the formula for the surface area of a right rectangular prism, which makes this a lot easier, especially since sometimes the diagram is difficult to see all 6 sides. And so really we can say surface area is equal to 2 times length times width plus 2 times length times height plus 2 times width times height. Okay? So this really, the explanation for this equation is that we have 6 sides on our rectangular prism. So if you zoom in here, we kind of have the base, right? So that's the base right here, 32t. But think about the opposite side of the base is equal to that, right? So the opposite side of the base is kind of the roof of the rectangle, or the rectangular prism. That's also 32t. Then we have this to the right, right? So think about this side to the right. Its opposite is equal to it, right? So that's another side. And then we have this side kind of over here, and its opposite is equal to it, right? And so all of these are really just found by multiplying either length times width, or length times height, or width times height. And then we multiply by 2 for the 2 different sides. So let's just work through this, right? The first thing for the surface area is 2 length times width. Well, we know 2, we know length, 8/3, but we don't know the width, so let's work on that. Well, we know that the area of the base is 32t, and we know that area equals length times width. So in this case, area is 32t equals length, which is 8/3 times width, which we're trying to solve for. So clearly, if we divide by 8/3 on both sides, we'll find width. So let's do that, right? Let's go to Desmos, and if you do 32 and then divide it by 8/3, you'll get 12. But don't forget the t, right? So we have this t here. So 12 times t is equal to w. And that's really the main complex part of the question. After that, we just need to plug in. Now that we have length, we have height, and now we solved for width. So 2 times 8/3, so we did 2, we did length. Now width is 12t. Okay, so we just plug that in right there. And now let's add this to the next part. So 2 plus 2 times length, which is again 8/3, times height, which is 3. And then plus 2 times width, which is 12t, times height, which is 3, right? All of these values were either given to us or we solved for them. When we do that, we're going to get 2 times 8/3 times 12t, right? So 8/3 times 12t is, well, let's just plug that in right here. So 8/3 times 12 is 32. So 2 times 32t, t is really just 64t. And then here we have 2 times 8 thirds times 3. So cross out the 3's here. Divided by 3, then multiplied by 3. You just get 2 times 8, so 16. And then here you get another t. So you get 2 times 12t, which is 24t. And then 24t times 3. So now coming back here, 2 times 32t, 64t, plus 16, plus 24t times 3, which is really going to give you 72t. Now let's finally add these up for the final time. 64t plus 72t, right? That is, let's just move to the left here. That is 136t. And then we have 16, so plus 16. So our final answer is going to be 136t plus 16. Let's see if any of the answer choices match up with that. And of course, one of them does. 136t plus 16. B as our answer. Done. Alright guys, so now let's move on to question number 3, and this is another geometry problem, but this is just one of those other SAT tricky triangle problems, and these actually, a lot of students have a lot of difficulty with them, so let's try to break this down. So the first thing is I just kind of drew a diagram of what they gave us, and basically they give us this figure. We have some right angles here, and I just drew that out here, and they basically said that the measure of ABD, so we have ABD, which means we're really looking at this angle right here, is W, right? So I have W labeled right here. And then the measure of CAD, so CAD, so really this angle right here, is Z. So I have that labeled as well. And then AD, so A to D, is 178, so I have that labeled as well. Then if the cosine of W, so cosine of W, cosine is so TOA, so adjacent over hypotenuse. So the adjacent of this angle is right here, so let's call this X, and its hypotenuse is Y, right? So if we're calling this X and then this is Y, then really we're saying X over Y is equal to 9 over 41, right? So the ratio of X to Y is the ratio of 9 to 41. And then we're saying if that's what cosine of W is, what is the value of tangent of Z, right? And tangent of Z is going to be our opposite over adjacent of Z. So opposite, let's say our opposite value is Z, right? So let's say if this opposite value of Z is, we just call this C, right? So this side is also called Z. Opposite, and then over adjacent, well, our adjacent is actually 178 right here, right? So that means if X over Y is equal to 9 over 41, what is Z over 178 equal to? So the best thing to do here really with this problem is to just draw it in a easier way to see, right? So I really just, if you take this shape, you kind of flip it over right, and you'll get this shape here, right? So you can see all these lines and points connect the same way, but it's a little easier to see, right? So this kind of gives you the whole triangle, right? This right here, this upper diagram, think about it like this. It's just one big triangle, and now because we've drawn a line like this, we've broken up into 2 smaller triangles. But what does that mean? Well, that means that this diagram represents 3 triangles, right? It represents this triangle like this, but then within it, we have this triangle, and then we have this triangle, right? The left, the right, and then the entire triangle as a whole. So this one just helps us see that, you know, besides the whole triangle as a whole, we have a 1 to the left and a 1 to the right. So, well, we know that the ratio of X, which is right here, to Y is 9 to 41. So, therefore, we can say that X over Y is equal to 9 over 41, then that means that X and Y, or X over Y, would be some kind of multiples of 9 over 41, right? So we can set, if X is equal to 9a, for example, that means that Y is going to be equal to 41a, right? So then, really, if we're just looking at this left triangle here, right, we have A to B to D. Well, we know that X down here is 9a. We know that Y over here is 41a. And then we have 178 here, right? But we actually don't want to keep it as 178. We want to figure out what it is in terms of A, right? Even though we don't know what a is, we can figure out what this is in terms of a because of Pythagorean theorem, right? So this side squared plus this side squared should equal this side squared, right? So that means 9a squared, but we'll just say 9, oh sorry, just opened something up, 9 squared plus blank or x squared should equal 41 squared. And that's going to give us 40, right? So we can see that solution Desmos is 40. So what that means is this side, which is 178, is actually equal to 40a, okay? Now coming back to what the question is actually asking us, right? It's asking us what is the value of tangent of z? Well, this side is z, tangent is opposite over adjacent. So opposite here is z, adjacent is 178. But guess what adjacent also is? It's 40a. So really, now we know that this is z, this 178 is also equal to 40a. Now, one last thing. We know that if we have one big triangle and we cut it to make two smaller triangles inside of it, those two triangles inside of it are going to be similar triangles, which means their proportions are the same. So the proportion of here x, right here, right, x to this side is going to be the same as the proportion of z to this side. So x to 178 is equal to the proportion of z to 178. Now, we don't really know what x is as a number, but we know that x is equivalent to basically 9a, right? And if we know that x is equivalent to 9a, guess what? This 178, we also know that's equivalent to 40a. So we have 9a over 40a is equal to z over 178, which is also equal to 40a, right? And since these are equal, that means that really this top, these two sides have to be equal, right? And so that means that our actual answer is going to be 9a over 40a. Well, guess what? We don't know what a equals. That's fine because we can cancel them out and we get our final answer of 9 over 40, right? And so our answer to this, just by using, multiple triangles, kind of understanding the similar triangles, is 9 over 40. And that's our answer to one of these questions from a past SAT. Done. Alright guys, so moving on to the next question. This one can be done entirely through Desmos, so I just have Desmos already pulled up here. And really this question is asking which expression below is a factor of this equation. Now the first thing we see is this equation has p's, but if we want to plug this into Desmos, we're just going to change those p's out with an x, right? The question doesn't tell us that p is a set constant, so we can assume it's a variable like x that can just change, which means we can say 49x to the power of 19 minus 121x to the power of 17. Now, which expression is a factor? Well, any of these expressions, if set to 0, will give us a solution. And if that solution that it gives us is also a solution for this actual equation, right? And a solution, again, is the x value when something equals 0, right? So what is the value of x when this equation equals 0? So if the solutions of them match up, that's how we know it's a factor. So we have this first one, and we have these three solutions to our equation. Let's see if any of these other ones match up. So 7x plus 11 equals 0. Boom. We can already see that matched up. That matches this line perfectly. Let's check our other answer choices before we commit to that, though. So then we can say 49x squared plus 121 equals 0. Well, you can see no line appeared. That's because there is no solution to that factor, so it clearly is not a factor. So we can remove that. Say 11x minus 7 equals 0. Now that gives us a solution, but it does not match up with a red solution, right? So you can see there's nothing there, and then we have this purple coming up. That's because the solution it gives us is not the same as one of the solutions from this equation. And then we can try negative 72x to the power of 40 equals 0, and there's no solution coming up. So again, the only one that has a solution that matches up with this equation is 7x plus 11, or 7p plus 11, which is a. So our answer is a. Alright guys, so now let's move on to our last question of the video, and this one, it seems really easy, but there's a simple mistake that most students make that makes them mess up and get this question wrong. So let's get right into it. The function f is defined by f of x equals the absolute value of x over a minus 16, where a is less than 0. What is the product of f of 17a and f of 8a? Right, so it seems pretty simple. We just plug in 17a
for x, and then we plug in 8a for x, and then whatever those values are, we multiply them, right? Seems super simple. I just wrote out the equation here. It's a little easier to see. F of x equal to the absolute value of x on top, divided by a, and then whatever that is, minus 16, right? So first we want to plug in f of 17a. That's to find the first value we need to multiply by, right? So most students are going to see this, okay, they'll say f of 17a means absolute value of x. I'm plugging in 17a for x. The mistake most students make is they say, well, the absolute value of 17a is just 17a, right? Absolute value of something is just if something's negative, it becomes positive. But this is already positive, so it just stays positive. 17a over a, right? That's 17, right? You cancel out the a's. Here is the key mistake, though. A is less than 0. They told us that. A is less than 0. I've written that right here. You have to keep that in mind. If A is less than 0, even though we don't know what A is, we know that it's negative, which means whatever's inside of this absolute value function is a negative value. And what happens to negative values inside of an absolute value function? Well, let's say that A was, negative 2. Then inside we have had negative 34. What's the absolute value of that? It's 34, which means if something negative is inside of an absolute value function, we multiply it by negative 1, right? So in this case, we may not know what 17a is equal to, but we know it's equal to something that's negative, which means what this actually equals is not 17a over a, but negative 1 times 17a, which is negative 17a over a. Now we can go ahead, cancel out the a's, and we'll get negative 17 minus 16, which is going to give us negative 33. We can do the exact same thing for f of 8a, right? So plugging in 8a for x, and that's going to give us absolute value of 8a over a minus 16. Remember the thing that I just said, right? It's negative 17. So this becomes negative 8a over a minus 16. Cross out the a's, we get negative 8 minus 16 equals negative 24. So now f of 8a equals negative 24, f of 17a equals negative 33. Let's go ahead and multiply those with Desmos, right? So this is from the last problem, but negative 33 times negative 17, that's 561. Let's go back to this problem. Sorry, wait, it was negative 33 times negative 24. So negative 33 times negative 24, right? Those are our two values. That's 792. And so, boom, that's our answer to the question. The product of those two values is 792.